I'd like to introduce Chris Tankersley. He is an amazing developer, an amazing person, and I feel so honored to work with him. I'm part of the team. He's going to talk about Get Simple APIs with OpenAPI, and I'm excited to see this, Chris. I hand it over to you.
Okay, thank you. I'm back, everybody. Sorry, I wasn't gone too long. So now that I'm done with my hosting duties, I'd like to talk to you all about OpenAPI. This is actually a project that Vonage has been involved with for the last couple of years, and it's something that we've put a lot of weight behind, and it's a tool that we have found to help us make better APIs, and especially get better information out to the developers as we build our APIs and we push out new products and all sorts of things. So we've been working with it the last couple of years. We use it in various aspects, but you can use this for the entire gamut of creating and testing and publishing your APIs. And I think it's a great suite of tools for anybody that's interested in building any sort of API. So what exactly is OpenAPI? Because if it's a tool you're going to use, you probably should know a little bit about it and what all kind of makes it up. Taken from their website, it is an API description format for HTTP APIs. So that is a really nice way of saying that it's just a specification. So OpenAPI by itself just is a way to describe your API in usually either a JSON format or a YAML format. And that's about it. The cool thing about it is the tooling and the ecosystem that has built up around OpenAPI. And the reason for that is the OpenAPI spec and its ecosystem has been around for a very, very long time. It originally started out of the Swagger project. So if you've used Swagger in the past, this is the current evolution of that. They've kind of handed that over to the community. And this is the open source version of this that the community itself kind of stewards and keeps going. Originally, it was written as a REST API format. And you can still kind of see that in a couple of things that we'll go over. It does lean very heavily toward a REST and REST-like API, but just about any sort of HTTP API that you would want to build, you can describe with this. Because again, a lot of this is going to be descriptive. It's the extra stuff on top of it, the extra frosting on the cake that really kind of pulls it all together. So there's a couple of reasons why you want to probably use OpenAPI. The thing that most people get out of it is documentation and documentation generation. So if nothing else, if you just document your spec in OpenAPI, you're putting it into a format that a lot of people can read fairly easily and understand with no additional learning curve. Especially the YAML format, and I know a couple of my coworkers will probably fight me on this, but I find the YAML format fairly easy to read and understand because it uses a lot of common verbiage that any developer should be able to kind of pick up and start to dig through and start to piece together. So the stock specs that it gives are great, but then you also get the tools on top of it. So you can actually take those OpenAPI specifications and use tooling to actually generate HTML documentation. So if you've ever seen like the interactive API documentation sites where like you put in your token and you find an endpoint you want to play with and you type in some sample data and hit go and it will return back a response. That is a lot of times documentation that's been generated by OpenAPI tooling or in the past by Swagger tooling. So a lot of people find that just the documentation they get out of it is amazing. At Vonage, one of the big things we get out of it is description as code. And this sounds very similar to a concept that's configuration as code if you've been dealing with things like Puppet or Chef or Ansible. And it's this idea that you have one central place that is very easy to read and update through just basic kind of text files that describe how something should work and things like that. So with OpenAPI, since it is a text-based specification, you end up with a fairly rigorous set of documentation that is not bound by any sort of program other than just a text editor. So we publish all of our specifications through Nexmo/API specification. You can go there and find any of our public APIs, pull down the specs, and use them for whatever you want. So in this case, this is our conversation API. But the nice thing is, as we go through and we create new APIs and we look at refactoring old ones or add examples to existing ones, we can actually just use standard GitHub pull requests. So I actually found a couple things a couple days ago. A new pull request came through for a new feature for an API, and I could go into the PR, see what was being changed, pull the relevant information out, and it went on from there. So you can use a lot of this in your existing tool setups. But again, it's just text files, but you get a single source of truth with it. You can go through and say that with like an actual built out API. But if you have someone coming in that's not familiar with the language or not familiar with how the project's set up, it can be very hard to understand when you get code changes come through. Textual based changes are a lot easier for people to kind of grok and understand what's going on. And I mentioned it a couple of times, but the tooling integrations are one of probably the best reasons to use OpenAPI. You can go to openapi.tools, and there is just a whole slew of different tools that you can use, not just linters and stuff to make sure your specifications look correct, but also things like full-on documentation generators, code generators, mock servers, all sorts of stuff, which a couple I'll touch on today. You can even build your own tooling. So if you go to developer.nexmo.com, we have published all of our documentation from the OpenAPI stuff as HTML documents. So this is using an open source tool that we put out called Nexmo OAS Renderer. But we take all of our OpenAPI docs and generate very complete, nice-looking documentation out of them. So the overview on the left-hand side, those are all descriptions out of the OpenAPI spec. All of the methods that are pulled out, those are all specified in the OpenAPI spec. All the examples, those all come from the OpenAPI spec. If we make a change to an API or I want to add a new example, I can go into the OpenAPI spec, make that change, and then our tooling will rebuild that. You don't have to use our tooling to get the same kind of benefits. You can wire up your own documentation generator, but the idea is the same. You can take this nice specification that is battle-hardened and mature and know that you'll have reliable tools either from some third party or that you can build yourself that will work very, very nicely. So those are usually the three things that most people get out of using OpenAPI. So with OpenAPI, I like to start with kind of designing an API, and you can come from both sides of this, both with a legacy API for an existing product you have, which is a lot of what we do, as well as coming from a greenfield application, which is part of what we do too. So as we build new products, we will run them through OpenAPI as kind of the design lifecycle for it. But also coming with an existing API, you can sit down and see how it was designed and where you may want to shave off some rough edges. So again, there's some things that the OpenAPI spec will go ahead and allow you to define, and there's 5 main areas that it kind of focuses on. The spec itself has a lot of different moving pieces, so I'm going to talk about 5 of the most common ones. But the fact of the matter is, even if you just focus on the basics, you're going to get a lot of good information out of this. The first part of any OpenAPI spec is the OpenAPI section itself, which is information about the API. So I'm going to focus on our voice API just as an example, because it's a fairly well fleshed out API of ours. But at the very top, we start off with an OpenAPI version number. This is mostly for tooling. So there are a couple different versions all the way back from the Swagger days. There's an OpenAPI 2. There's a couple versions of OpenAPI 3. So this API was built against 3.0. I think 3.0.3 recently came out. So this mostly just helps with tooling to understand how should I read this document, and that's about it. Then you have an information block, and this is information about your API. And again, this is mostly descriptive. There's really not anything in here that influences how your API is built. So we start off with a version number. You can use this if you want. You don't necessarily have to. We use it strictly internally. So I know the difference between 1.2.5 and 1.2.4. If we make a breaking change, we know whether or not we need to do a major version bump or if it's something that can fall under minor, because we tend to use semantic versioning for a lot of our APIs. But this is just strictly internal, doesn't actually have to show up anywhere in the API itself. Then we can give it a title and description. If you are like us and you have multiple APIs, this helps people kind of narrow it down, especially if you're publishing APIs that have like internal names or things like that. Ours are fairly succinct. We've got voice, we've got SMS, things like that. It's pretty easy to figure out which spec is which, but you may have internally different code names. So this will give you an idea of what is going on with the API itself. And then because we're good stewards of open source projects, we give out contact information to where you can get access to things. So if you're publishing your own API, you can give it an email address and a URL where people can get support. So in our case, you can email devrel@nexmo.com or go to our documentation site, get additional information. But this is contact information for anybody that's using your API. And then at the bottom, we have the server section. And this is starts to form the basis of where your API actually lives. So in the case of our voice API, anything that we define in this document should live at api.nexmo.com/v1/calls. So any routes we defined will have this prepended to it and should work perfectly. And one thing I would like to point out is we do have v1 here in this URL. That is strictly a naming convention of ours. It has nothing to do with the version number up here. OpenAPI does not force you to use versioning in your APIs whatsoever. So the v1 in here is just a consequence of that's how we named those routes originally, and so they show up on here. The next part is probably where you start getting into where it makes the most sense for developers to start looking, and that's what endpoints are available. If you've ever tried to grok through some documentation and you can't figure out what the endpoints are, that's a big problem for a developer, because we need to know what we need to hit. So underneath the information header section, there will be a key called paths. And this is all the individual paths that are available for this API. So in the case of our voice API, we have a slash or a root, and then we have /UUID, /UUID stream, and then talk and DTMF. So this API at most has 5 routes. That's it. Anything else should generate a 404. If we have documentation referencing anything else, then we either need to implement that endpoint or we need to fix the documentation. But we can also see here that we can do placeholders. So UUID, by virtue of being in the curly brackets, indicates that this is something that will change. It's a dynamic part of our URL. So we don't have to worry about just static URLs. We can actually design dynamic URLs as well. Now, once we know where we can actually hit, we need to know what we actually need to send to the API. This is another one of those things that it can be extremely frustrating for a developer to have to figure out to do, because different APIs are built differently. Even if they say they're REST, they may not fully conform to the REST style of building an API. Legacy applications may behave a specific way because of the framework that they're built in. You may do some weird things between get and post and all sorts of things. But even if you do, you can document what those requests look like. OpenAPI isn't going to care. The big point is you get it documented so that developers understand what's going on. So I kind of mentioned that OpenAPI is a little bit REST focused, and you start to see that kind of right away. But even if you're building something like an RPC API, which uses just generally get or post, you can put those in there so you can start to understand where routes and things can be used and what they do. So the first thing we do is we define what verbs are available for a path. So I'm going to focus on the root path. That only has a post and a get. Any other verb that gets sent should either throw an error or a 404 or something like that. We want to make the expectation that you can't just arbitrarily throw verbs at a route. Whatever the documentation says, that's what we should respect. So in this case, a post and a get. And if you follow REST, you probably can start to glean what's going to end up happening with some of these. So post is probably going to be a creation path. Get is going to give us a list of a whole bunch of things. So you can already start, without any documentation being put in here, start to try to guess what's going on with these. So as we dig further into the get section, we can fully flesh out what goes into each individual verb and route and how those work. So each of these verbs, we can give it a summary. So if you just go to / with a get request, we will get you the details of all of your calls. Description, I'm pretty sure, is the exact copy of that, but you can make the description whatever you want. Some of our APIs, they actually have HTML in the descriptions. So you can get as complicated or as verbose as you want with the descriptions. Operation ID is kind of a tooling key. So if you auto-generate code or documentation, this will generally be a naming convention. It doesn't really impact how the API works, but it's a good idea to put them in there. It also helps you kind of sit down and think about, well, if I was building code for this, what would I call this method? And things like that. And then we get kind of into the meat of the request. Get is pretty easy. Most GET requests have some sort of query parameters, so we can define those in here. So we know that we're going to have at least one called status, and it's going to go in the query. And you may ask, well, why do I have to specify if it's in the query? There are plenty, not saying our APIs do this, but there are plenty of APIs that will actually allow you to send a request body in a GET request, which isn't really standard, but OpenAPI will let you document it because sometimes people will do that. So you can go in and define whether it needs to be in the request body or in the query, give it a description. And then one of the most important tools I think you get out of this is, what is that data supposed to be? So in this case, status is going to be a string, and we give it an example of started. So without any additional information, I know that status is probably going to be some English word all in lowercase, and probably a past tense verb based on it being started. We actually flesh this out further in the real spec. We actually give it an enumeration of all the different statuses, so you can go even more fine-grained than this. But with this, you can start to define what parameters are expected, where they're expected, and what that data type looks like. The data type is especially crucial because there are a lot of languages that do dynamic typing. I tend to do PHP, which does dynamic typing. JavaScript does as well, Python, Ruby. So knowing what the actual data type is can really help us influence how we send data to an API, but also we can set expectations as API developers for what we're expecting to come in. If status comes in as a 1 or a 0, I could outright reject that without even checking what the data was, other than just simply, is it a string versus is it an integer? So you get some, you start to put that expectation out there for error handling and things like that with the request structure. Now, once we've sent a request, we kind of need to know what the response looks like coming back. This is vitally important for anybody consuming an API, because it can be extremely frustrating if you don't know what the responses look like, or if they're not consistent, or if things are named differently. OpenAPI won't necessarily help you fix inconsistencies, but it will help you decide where those are and hopefully refactor those out at a later time. So under each of the verbs, we can have a responses section. And this, again, kind of shows the little bit of restish nature of OpenAPI. But these are broken down by return code. This can get a little bit messy if you have a single return code, but multiple things come back. For me, that kind of is a code smell. Like, why am I returning a 200, but multiple types of data responses? But all kind of depends on your API. But we can give it a description. So in this case, a 200 is okay. That means everything kind of worked. And then you can return the actual content itself. So you can break this down by header. So in this case, we're going to say, if you ask for application JSON, this is what the return type will be. If you want to accept XML, or they say that they accept XML, you can lay out what that schema looks like as well. So if you have minute differences between them, you can lay all that kind of stuff out. So in this case, we're going to say, if you asked for application JSON, we're going to return an object as opposed to like a JSON array. And at least one of those things will be something called count, and it will be a type of integer. And of course, our responses are much more larger than this. But this gives you a breakdown of, you can actually fully define what those responses will look like, so you can make a better informed decision on what data you should be pulling out. Even if you're inconsistent, at least it's documented. And someone can say, well, here it's call ID, and over here it's call UUID. We're pretty consistent with the voice stuff, but you can make those decisions as you go through. So one of the things that you can do to help make your data consistent, however, is using references and components. So this is a part of the OpenAPI spec that allows you to define reusable sections of code, not only just with responses, but data types, request bodies, response bodies. all sorts of things. So we don't have a really good full example in the voice API, so I'm going to steal this from our conversation API. But on the main root call of our conversations API, under responses, you'll see this, and it says $ref, and then gives a path. So components, responses, conversation light. Later in the document, you can have a component section with all of your reusable pieces of code. So in this case, conversation light has its own schema, and we can see kind of looking at that it's going to return a JSON object with an ID and an href and a whole bunch of other things. But we know what that will look like, and that will be consistent anywhere that we say conversation light should come back. And each of the components can reference other components themselves. So in this case, ID, we can just say, oh, go reference components, and I don't remember exactly where it is in the page structure, but you can go to the specific reference, and that ID will be defined as a string with its own example and all of its relevant data in one singular spot. And anywhere we use ID, we can reuse that component. So it makes it much easier to actually sketch out where you want to have components live and where you can get that reusability, and then build on top of all of those things. So you can go all the way down to the property level and all the way up to big giant chunks like responses and request bodies. And then finally, I kind of glossed over it a little bit because technically it's part of the request, but you can actually specify authentication methods as well. So if we pop back over to the get section, I've added a couple of lines here, and that is a security section. So in OpenAPI, you can define exactly what authentication you expect. And if you are in a mixed authentication environment, kind of like ours with our APIs, some of them use token secret, some of them use a token bearer in the header. You can specify what those are. You can also specify which ones have security and which ones don't. So it's not kind of an all-inclusive thing. You may have a partially public API and then a partially secreted one, or one that you can define that if you pass other things, you'll get more additional information. So you can actually go through and define what that security is, and that way people will expect what is there. So those are the main 5 sections of the OpenAPI spec. I'll post a link to these slides afterwards where you can get the full URLs from each slide, but I've kind of put the URLs for the individual sections API documentation at the bottom there, so you can always go back and reference. There are many more sections of this, but even if you're just starting out, this will get you a very long way down the road to getting a very well-documented API. Now, you may say, Chris, I hate writing XML, and I will totally agree with you. I hate writing XML as well. I don't like writing JSON either, especially some of these documents. They can get very, very long. So because OpenAPI is a specification, and good specification breeds good tools, you get tools that help you actually write these things for you. One of the ones that I love the most is Stoplight Studio. Studio is a project put out by the Stoplight group, and they tend to do a lot of OpenAPI tooling, and a lot of it is open source and completely free. So it's not like you're getting a stripped down editor by using their stuff. It's fully open source. I know a couple of people that work on the project. The project is extremely vibrant and well used across many spectrums. So Stoplight Studio is basically an IDE for building an OpenAPI spec. They have a Mac app, a Windows app, and a Linux app. There is also a web version, so you can actually use it hosted through them or host it yourself. So you're not really locked into anything. So this is an example of that GET request we've been looking at so far. So if I open this up in Stoplight Studio, we get a couple of sections. We get a reference section over on the left with some overviews, and then we get the actual bulk of our API, what we're working on, in the center. So this has all the same information that we had before. So we can see our base URL there at the top, api.nexmo.com/v1/calls. And then we can see the route that we're working with, / if this had parameters, we could define additional parameters up here at the top. There is a get and post tabs lit up because we've already predefined what those are. But if we needed to add put, patch, delete, whatever, we can add those in there and they would light up as well. We can see the operation ID pulled through. So get calls is what we called it in the spec. And it's able to pull that through, and you're able to set that. And we have our description there, so get details of your calls. Security's there as well, so we see our bearer auth. It's just a drop down, so you can pick what kind of authentication we have. And you can see it just peeking up just a little bit there is the status query parameter. So you can define all of your query parameters through here. So everything that we could write out in the XML works fairly well in here. Over on the left-hand side, you'll get a list of your APIs you're working on. In our case, OpenAPI basically recommends one spec document for every API that you publish. So you may only have one API, and that may be it. That's totally fine. We break ours out by product, so we have multiple APIs by our product lines. But if you are doing a simple application, or you just consider it all one massive API, you could put it all in here. So I've just imported our voice API file. So I've only got one here. If you pull down our GitHub repo, it'll pull in all 20-ish APIs that we have set up. And then down below that, you have an overview of your API. So these are all the paths I defined. So I have a slash, I see our slash UUID, DTMF, talk. I can see what verbs they accept. So you get a real quick overview of what's going in on here, and you can click back and forth between all of these things. So Stoplight Studio is great. There's a couple rough edges with it. Like we found out yesterday, it doesn't support request body components directly in the IDE. It doesn't stop them from being built. It just doesn't expect them to be there. There's an open issue for it. But again, it's a fairly active community, so I'm not really worried that something that's been sitting out there won't be looked at. They've actually been still discussing how that should work. So there's a couple rough edges, but for most APIs, this will work. The really nice thing about it is, again, not only is it open source, there's no vendor lock-in with this either. There's no special setups you have to have or configuration for it to work, because in the back end, all it's doing is building OpenAPI YAML in this case. You could have it output JSON if you really wanted. It's just writing a YAML file to disk. That's it. If you go find this project on your hard drive, it's just a bunch of YAML files. That's it. You can move those YAML files into some other tool, some other project, and use this just for skeletoning. We don't use this a ton for building out our APIs, so I will sometimes just dump a file in here just to get kind of the overview without having to dig through the YAML. But in the end, all of this OpenAPI YAML and stuff is just used to influence the UI, and then the UI will write out YAML. That's it. Once you've kind of start to put together your API, you really should start to use it. And the quicker you can use it, the quicker you'll find those developer issues where, like, it's I don't want to have to call all the data here or make multiple API calls, things like that. So because the spec is mature, we get mature tools. We get things like prototyping and mocking APIs. So one of the first ones I used was actually Prism. This is a command line tool that they offer. It will take an OpenAPI spec and mock out a server with basically one little command. So you write your spec either by hand or in Stoplight Studio, doesn't matter, because it's just a YAML file, and then you can run it through Prism. So I popped it up into Prism on here. So you just do Prism mock, give it a YAML file, and it starts up a server. So I have a server running on 127.001:4010, and that has all routes defined and a couple sample routes for my spec. It did this completely off of the specification. I didn't have to define anything other than the spec itself. So we see our slash on post. It gives us a sample GET request that we can hit. It gives us a couple that have the UUID filled in. And all I did was start Prism. I didn't have to configure Prism at all. It's all in the spec. So I can go to a tool like Postman, and I can take that sample GET request with all the query parameters. I can paste that in, and I get back a live representation. All of this information is pulled from the examples in our OpenAPI doc. If you don't have examples set, it will actually go through and try to auto-generate some like lorem ipsum values. So sometimes you get some really weird data. Sometimes phone numbers don't generate properly because we don't have good examples for them. But we can see here, like the UUID is actually the example UUID in that spec. And it comes through. I can validate that that's correct as long as our examples are all good. But I can take the specification, set up a mock server, and make sure that it actually works, that it functions. Altruistically, on when I'm doing development work for a lot of the stuff I do, working on the PHP SDK, I will run this as the first baseline so that I don't have to hit production all the time. There's been plenty of times pre-pandemic where I have booted up a server on a airplane or in my hotel room because the internet's not great, and just run the mock server. I don't have to have access to a production server to test these things out. If you want to get a feel for an API and they publish OpenAPI docs, running Prism and a mock server is a great way of handling that. If you don't want to run a command line tool, or you're already using Stoplight, Prism's actually built into Stoplight Studio. So down in the corner, there's this thing that just looks like a little status indicator that says mock server. It technically is a status indicator, but if you click it, you'll get a little pop-up of all the routes and things that are available that it's running in the backend. So here, if we zoom in a little bit, I can see on localhost 3100, I have a /UUID DTMF with put, some delete requests. All of this is automatically generated and run by Stoplight Studio. So same idea, I can go to localhost 3100 / and get back a response. Depending on the tooling and when things are installed, the Prism is giving a little bit better example in this because that's a relatively newer install than the Prism or the Stoplight Studio I have installed. But under the hood, it's just running Prism. It's just mocking a server, and you can start to test with that. And there's two edges that go along with this, speaking of tooling. So I'm using Postman. This will also work if you use Insomnia, which is another API client. But Postman will actually consume an OpenAPI spec as well. So as I'm building this, I can actually import this into Postman, and it comes in as a thing called a collection. And I don't have to manually put in my routes anymore. So it actually pulls up that I have a route request with get and post, and that there is a UUID request, and then stream and talk are under there as well. So you can actually take a fully functioning OpenAPI spec, import it into Postman, and start to use it. Whether or not you want to hit a production server is up to you, and you're mocking it. But you can take that spec you've been building or that spec someone else has given you and use that to go ahead and start bootstrapping your working with that API. Now, once you've gotten kind of happy with your API and you've mocked it out and stuff like that, it would be really great if it starts to actually becomes usable to outside people. So there's two sets of things that you can do and with OpenAPI spec to actually generate code. One of those is actually generate your server stubs. So if you are rapidly prototyping out an API and you want to see how it works, you can actually generate a skeleton project based on your OpenAPI spec and be out the door running and just have to wire in your data. So they have tons of languages out there already, ASP.NET, Golang, Java. There's quite a bunch of them for PHP. Node.js, unfortunately, only has an Express one, but it actually builds a fairly nice Express app. So if you're using a language or you're thinking about porting something over to a new language, you can use this to very quickly get set up. So they have a tool called OpenAPI Generator. You can install it through NPM, or they have a bash wrapper script that does some auto updating, in which case it'll be called OpenAPI Generator CLI, which is the one I have installed. And it'll do a couple different things, but for the most part, you just tell it you want to generate something. You give it a YAML file. You give it a generator you want it to run. So in this case, I'm going to run slim4 and an output. So I just want to put it in a server directory. So if you click, if you type that all in and run it, it'll chug for about 15 seconds and you get an API out of it. So this is a slim4 application that I did nothing more than run that generate code. I get a set of default routes. It has logic already built in for setting up the routes themselves. So if I hit /, it understands how to route it to get calls. And this is the default code that it gets there. So we can see I'm expecting a set of query parameters. So it's actually going to pull out of the PSR7 query parameters. PSR7, if you're not familiar with PHP, helps define what a server request and server response looks like and makes it easier to work with. So it's going to say get all the query parameters, and then it's going to do some default settings. So if I want to have default values, I can set those up. But it knows that I'm going to have a status, a date start, a date end, a page size. Things that I would search for based on the OpenAPI spec, it automatically pulls out. And then all I have to do is implement that. So you'll notice right here, it says it'll actually throw an exception because I haven't actually changed this to do anything. But I can take all of that incoming data, push that into a service layer, talk to a database, whatever, and return that information. And all I have to do is just go in and fix these and wire up these individual methods. If you don't like Slim, let's say you like Laravel, all I do is change one little generator. So instead of PHP Slim4, I'll just do PHP Laravel. And I get a Laravel application, and it's properly built. So here, under the routes folder, I get an API.php file with all of my routes defined. So if I hit /v1/calls, it'll go to default controller, create call. If it's a post, if it's a get, it'll call get calls. So it all sets all that stuff up. All of the method names and things like that are all generated off the operation ID, which is why it's a good idea to define those. But it goes through and sets all that up. I can go into my controller. So this is get calls. And we'll see it's slightly different because Laravel does things a little bit differently. So instead of getting it from a PSR7 request, it's going to go to the request facade, grab all of the request info, and then put that into an array, and then we can start to work with it on there. So here we actually see an example of if the page size is greater than 0, it'll automatically throw an exception on that, because I believe we have that defined in our specs. So the code generation is really, really nice. I would say this is really great for prototyping and getting up and running very quickly. It does do some things you wouldn't normally do in a real application. So I wouldn't have one giant default controller for everything, be it Slim or Laravel or anything like that. But if I'm prototyping out an API because I'm just not sure if it'll work or whatever, this is a really quick way of doing that. And by using the framework things, if you're already using something like that, if you're in a Spring bootstrap shop, output it as Spring, have your developers work with it. They'll already be familiar with that environment. You're not stuck with a specific language. So this is a great way to get a fully working API up and running fairly quickly. Now, the flip side of that is, and which I think most people probably actually use this for, is the client side. Now, this is not something we do at Vonage. We actually write all of our SDKs mostly by hand. So that way we have a little bit more control over what the SDKs look like. But you can actually generate an HTTP client from your OpenAPI spec and very quickly get that going. I've used this a couple times with services where I'm using a language that they don't necessarily support. So I'll take their OpenAPI spec and generate my own SDK and get that to work with. So again, there's a whole host of languages out there. They're not tied to frameworks, so this tends to be a little bit more generally focused toward just a language specifically. But again, you've got ASP, you've got Golang, you've got Node, you've got PHP. The nice thing is it's basically the exact same idea. So we're going to generate a server skeleton, we're going to generate an SDK skeleton. The only difference is I changed the generator. So instead of saying PHP Laravel or PHP Slim 4, I will just pass it PHP because it's just a language construct. So I'll put it to an SDK directory, and we will get an SDK. Again, it's not probably the best structurally, but it actually works in kind of a pinch. So here we can say we have a default API class that's going to have all of the methods that we can call on it. So since we defined a get call operation in our spec, we can say here's a get call method on the API. We know that if we do /UUID, it's going to expect some sort of UUID to come with it. Then you can fill that in. And it has all the HTTP stuff underneath it. And then you can go through and write out fairly quickly out of the README the actual usage part of it. So we can write an OpenAPI spec, generate an SDK, and then in roughly 16 lines of code, with about half of it being set up, get a callback. And if you point it to like Prism or Stoplight Studios mock servers, you can start getting data back right away without having really generated any code yourself. Again, this I think is really mostly just for prototyping. I don't think I would ever want to have to deal with an OpenAPI generated SDK all the time. Some of them, the object structure can get a little bit funky, but it's great for just playing around with or evaluating. One nice thing you can use out of it is the object structures. So this is something we've investigated with the Golang library, actually using, and the Thunder's really angry that I mentioned Golang apparently, using the structs that it generates to make, to cut down on some of the work we have to do. So even if you don't use the full generated set of code, you can pull some pieces out of that and start to use that fairly quickly. So 16 lines of code, pointing it at a mock server, we've actually got fully running code that we can deal with. So to kind of sum it all up, OpenAPI is really, really great. I love the fact that we use this. I use this a lot now in my own personal projects because of that. So remember, you can use this, if nothing else, to document your API. Developers love documentation, and they love well thought out documentation. Doesn't have to be markety. You give me a YAML file, I will figure out how to make it work. The fact that you have documentation is a big plus, and that's one of the reasons why we put that out. Using the toolings, you can build your API and you can test your API very, very quickly. While we don't use the OpenAPI specs to generate our code at Vonage, I can use that for a lot of the demo codes that we use, for a lot of the small projects that we do, and make sure things work. So I don't have to spend a ton of time building everything from scratch with a bunch of boilerplate code. I can just type some schemas up in a YAML file, generate a bunch of stuff, and go from there. And if you do go the full gamut through, you can fast track a lot of that development because you can generate a good chunk of that server code. You can generate a good chunk of that documentation. You can generate those first SDKs that you want to build and get those out to customers so that way they can start using them right away. Or even if it's an internal tool, get those things wrapped into the people that are going to use it quicker than you might expect. So I really love it for prototyping. And you get some really nice, well-informed decisions that you might go to on your actual production level code. So I know I'm a couple of minutes early, but if anybody has any questions, you can find me on Twitter as DragonManTank. You can hit me up at my email address, chris@staychristly.com. And I'm sure we probably have some Q&A questions, which I'll gladly take now. But otherwise, I'll be around for the rest of the day in the chat if anybody wants to chat with me. Otherwise, again, find me on Twitter. And just about anywhere you see DragonManTank, that's probably me. So thank you very much.
Thank you, Chris. That was an amazing talk. It was actually enlightening. We do have questions. And the first question is, can anyone use the renderer you were showing off earlier? Sorry.
Yeah, so the one that's from Nexmo, like I said, I'll post the slides. We'll hop back there real quick, and it's probably going to do all sorts of fun things on streaming video. But if you go back to, I'll get you the link. Here we go. GitHub.com/Nexmo/Nexmo-OAS-renderer. That is an open source project. You can use that with your OpenAPI specs to generate that. You can tweak the CSS and layout to your liking. There's also generic ones out there already for some of the more interactive ones. Ours is not necessarily interactive. It's very much meant for reading, but there are tons of documentation generators out there, including ours.
That's amazing. The next question is in the likes of the first one. It's what alternative renderers are available? If you could suggest a couple.
Yeah, so there's a couple. If you go to openapi.tools, there's a whole bunch of them there. I know the OpenAPI generator ships with a Node.js one that will generate the nice interactive ones. I think it's just called Node.js. Node.js-server, I think, is the one that will generate it. Their actual Node, the Express app, ships with the documentation generated. Usually I go through and I just use, I find one on OpenAPI tools. I don't have one that I find specific that I like. Most of the times for my personal projects, I'm bad and I just publish to OpenAPI docs. I don't build full-on documentation. So, but our OAS renderer is actually a really nice one to use. But otherwise, like I said, OpenAPI tools has a huge list of tools out there to use.
There's another question. It says, what React-friendly client-side library for mocking API responses?
That I don't know. I don't do a lot of front-end JavaScript work or React. For me, if I'm going to be mocking responses, I would probably run an actual server in the background. So either Stoplight Studio or Prism, not like having to actually build like a full-on server. To mock those, I would say that you really want to make sure that the data transport layer works. So React should ask for data from somewhere else. And in that case, that's where like Prism and Stoplight Studio can really help. I would do that over having something running in the browser to actually generate and return that data. There may be generators out there, but that's I would probably run just an actual mock server in the background.
Excellent. Well, thank you so much, Chris. I really enjoyed your talk. It was insightful, and I'm really excited about OpenAPI. This is also one of my favorite subjects, and you know, taking the opportunity to tell you how much we appreciate you. I appreciate you, and I think you do an amazing job. I love your talk. You're awesome, Chris.
Well,
Thank you so much.